The Apache Mesos connector for IBM Platform Computing products allows both Apache Mesos and IBM Platform Computing products to share the same infrastructure. It adds IBM Platform Computing resource sharing policies and management capabilities to Apache Mesos and to the Apache Mesos framework. We start with the Mesos GUI. The Frameworks page shows that we do not yet have any active or terminated frameworks in this Mesos cluster. The Slaves page shows information about Mesos slaves in the cluster, and we can see we have 4 slaves connected. We also have a link to the IBM Platform Management Console. We log into the console where we can see all of the cluster information on the dashboard. We can go to the Hosts view where we see 4 hosts. These are the 4 Mesos slaves we just saw. We start Marathon with Mesos role Marathon 1 within Docker, then Kubernetes service with Mesos role K8S1. Now from the Mesos GUI, we see we have 2 frameworks running, Marathon and Kubernetes. Next we can configure the resource plan for each consumer. We can see we now have 3 consumers, including K8S1 for Kubernetes and Marathon 1. We want to make sure the Marathon long-running service keeps going, so we increase its priority level to 1. We also want the Marathon framework to be able to reserve one host and prevent other frameworks from launching tasks on this host, so we enter 1 in the reserved host field for Marathon. And we can check on resource information for each consumer. Now we use Marathon to create a WebSphere service, including configuring Docker settings. Once we hit the Create button, we can see that the application is running. We can also see that the task is running from the Mesos GUI. On the Resource Plan page, we can check consumer resource usage. Consumer Marathon 1 has 1 resource allocated. Now we use Kubernetes to run 2 tasks. On the resource allocation page, we can review resource usage. The Marathon consumer has lent out 1 of its resources, and consumer K8S1 has 2 resources allocated for its 2 tasks. This shows how available resources can be shared between frameworks to meet demand. But a high-priority framework can always reclaim a resource if needed to meet a quality of service guarantee. Here we will get the Marathon framework to reclaim a resource that was borrowed by Spark. We configure and start up a Spark cluster. The application instance we created is listed and ready to run, so we can go ahead and start it. Now the application instance has started, and we can see it has 3 worker nodes here. And from the hyperlink here we can access the Spark portal. The Spark cluster has 3 worker nodes, all of them showing as alive. Back in the management console, we can see that Marathon has lent out 2 resources, Spark has 4 resources allocated, and Kubernetes still has 2. On the Marathon portal, we scale up to request 13 application instances. This will cause borrowed resources to be reclaimed for the high-priority Marathon service. Back on the resource plan page, we see that the Marathon consumer has reclaimed its loaned resources. And returning to the Spark cluster, we see there is only one worker here now. The other two were terminated in order to return the resources to Marathon. The Apache Mesos connector for IBM Platform Computing products maintains 100% API compatibility with Apache Mesos frameworks. It simplifies management by providing a central management console to dynamically manage tenants and configure resource sharing policy. It provides advanced resource sharing policies to Apache Mesos frameworks, including policies for multidimensional lending and borrowing, ownership, priorities, and time windows. It provides guaranteed quality of service to Apache Mesos frameworks. It allows Apache Mesos frameworks to better optimize task scheduling by providing an enhanced view of resource status. And it improves Apache Mesos framework performance by providing the ability to permanently cache resource offerings. For more information, please visit the IBM Platform Computing Products Connector for Apache Mesos webpage.